We're going to balance this redox equation in a basic solution. Both balancing in an acidic and a basic solution, when you use the ion-electron mode like we've been using in class and in your textbook, both systems start with the same 7 steps. In an acidic solution, after the 7th step, when you add the two half reactions together, you stop. In a basic solution, you have 3 additional steps. This example is in a basic solution. So at first, you're going to divide the reaction into half reactions. So one half reaction has the chromium compounds, or polyatomic ions. The second one has the sulfur-containing substances. Okay, and then I'm going to balance each half reaction independently of one another at first. So first balance everything except oxygen and hydrogen. So I look and there's one chromium on each side, so that's balanced. Second, you balance the oxygens by adding waters. So I see that I have 2 oxygens on the reactant side and 4 on the product side, so I add 2 waters. That will give me 4 oxygens on both sides. Then I balance the hydrogens by adding H+, so I would need 4 H+. And then finally, I'll balance the net charge by adding electrons. So carefully I look. On the reactant side I have 1 negative. On the product side I have 2 negative here. There's a positive, but I have 4 of them. So that means on the product side I have 4 negatives. So to balance it, I'm going to need to add 3 electrons. So both sides then will have a net charge of 1 negative. Now on the second equation, I'll start by balancing the sulfurs. I need to add a 2. I look at my oxygens carefully and I have 8 oxygens on both sides. And then I have no hydrogens, so I don't add the H+. And so lastly I balance the net charge. Reactant side has a -2. The product side actually has a -4, so I'll add 2 electrons. Now I'm going to need to add these 2 half reactions together, and in order to do that I have to have the total number of electrons the same on both sides. So to make that happen, I'll balance the first half multiply the first half reaction by 2 and the second half reaction by a 3, giving me 6 electrons on both sides. I'm going to rewrite the half reactions below so we can see. Remember, I'm multiplying by 2 on the first one, and I want to be sure that I multiply by 2 the entire way through on both reactant and product side. And then on the second half reaction, I'm going to multiply by 3, again the entire way through. Now I'm going to add these 2 half reactions together, canceling anything that I have on both sides that are the same. So in this case, the only thing that I have are the same are the electrons, so that will cancel. And then I'll rewrite the equation with the remaining substances. These can get kind of long. Sorry for the delay. 8H+. There's a plus in there. Okay. Okay, if this were an acidic solution, then I would have stopped here. But since it's a basic solution, I have to do 3 more steps. I'm going to add the same number of hydroxide ions as I have H+ ions. So I have 8H+, so I'm going to add 8 OHs, And I have to do that to both sides. Now on the side with the H, sorry, on the side with the, I keep hitting it, I'm too close to the corner. Oh my gosh. Okay. Sorry, this is not, I keep hitting the next page. There we go. So I add these two together because H plus and OH minus make water, and I get 8 waters. So then what I can do, now I have water on both sides, so I can cancel out some of the water. So this side has 4, so I'll get rid of all 4 of those, which will leave only 4 on this side. So now I can add everything together. So I have the 8 OHs, and then I don't think everything on this side will remain the same. This O4, 2 minus, except I'll have 4H2O. And so that finished balancing the basic equation.